All right, our first lecture has come to an end. So let me summarize what we have learned today. Yeah, there's been a lot of stuff to digest and to take away from this lecture. The main takeaways are, so the process of constructing a machine learning model is referred to as training. Now, we have a lot of observations, and we need to split our all observed data that we have into training data and test data. So in test data is an independent data set. It is set aside so that we can measure accuracy of our model. So how do we measure accuracy of our model? So we have learned about regression models and classification models. Right? So within supervised learning, we have regression and classification. So regression models can be so their accuracy can be measured by the mean squared error or the mean absolute error. So the smaller the error is, the more accurate the model is. So accuracy of a classification model is measured by the overall error rate or by cross entropy. Later we will learn more metrics. So more metrics are usually needed when our data is imbalanced. So when we have something like, so one class is much more frequent than other classes. Then other metrics will be useful. And this is probably the most important of all, is that to get an independent estimate of how good our model is, we apply it to a test data. So it is extremely important to always have test data and a training data. So at least if we care about accuracy of predictions whatsoever, then we need this test data. Yeah, maybe I should mention it that there are kind of two types of problems. So one is prediction, another one is inference. So if we care about accuracy of prediction, then we need test data. So here is a checklist of concepts. So we have learned supervised and unsupervised learning, regression and classification. So this is within supervised learning. So supervised learning is kind of subdivided into regression and classification. So how to measure accuracy of a model? For regression and classification, training, validation, and test datasets. So validation is somewhat validation dataset is somewhat exotic. So the important ones are training and test datasets. Then we have reviewed linear regression, and we have introduced a new model, KNN, K nearest neighbors. Parameters versus hyperparameters. So recall that linear regression has parameters, beta 0, beta 1, and so on, beta p. KNN has this hyperparameter k, and the difference is that we can only find the optimal value of a hyperparameter by trial and error. So we just choose several values of k, try all of them, and pick the one that has the smallest error. And if we do that, then we need some kind of a validation set. So because we pick the value of k that yields the smallest error on the validation set. And finally, overfitting. So overfitting happens if our model tries to approximate not just the true process there, but also the random noise. Okay, so this is all for today. If it's been too much to digest, don't worry. We're going to have labs and tutorials. If you have questions, please post them as comments to my YouTube videos.